In this example, we'll look at finding determinants using two methods, Sarrus rule and Laplace expansion. We'll use example 7 from lecture 11. Just to recap on Sarrus rule, we have our 3x3 matrix, and this only applies to 3x3s. We take the first row, put it there, second row, so we end up with a 5x3 matrix. We apply a simple rule. We go diagonally down, starting at A11. So we'll have A11, A22, A33. We multiply those together and give them a plus sign, and so on for the next diagonal, starting at A12 and A13. Next we start at the bottom left-hand corner, A31, go diagonally up. We give these multiples a negative sign, so we have A31, A22 and A13 multiplied together with a negative sign, and so on. So we sum those up and we have our determinant. Let's have our expanded matrix then for example 7. Starting at the top left-hand corner position, we'll have a plus there, down, down, plus, down, down, plus, down, down. So determinant A is equal to plus 4 by 2 by 0 plus 2 by 4 by 6 plus 9 by 1 by 5 minus 6 by 2 by 9, 5 by 4 by 4, 0 by 1 by 1. 6 by 2. And that's equal to 0 plus 48 plus 45 minus 108 minus 80, 5 by 4 by 4 minus 0, and that's equal to minus 95. We can also find the determinant using the Laplace expansion, and then we can think about which column or row it's best to expand along, taking advantage of any zeros that might be present. So the Laplace expansion, what we do is to expand along usually a row. We take the first position in the row, delete the corresponding row and column, and find the subsequent minor, give it the appropriate sign, and then multiply by that element that we started with. Looking at, say, expanding along the second row, so this would be this case here. We go up to our matrix. We start with A21. That's our coefficient. Determine the sign for our cofactor. So it's minus 1 to the power 2 plus 1, so it'll be a negative sign. Or if you want to just remember it, the even numbered rows start with a negative sign and the odd numbers start with a positive sign. So we inlay the first row and the first column. The elements to the left form the minor, A12, A13, A32, A33. So that's the minor there. The minor plus the sign is equal to the cofactor. We find the determinant of our minor, and then we go on to the next element. We go from A21 to A22. Our sign then is minus 1 to the power 4, 2 plus 2. Eliminate the column and the row. We're left with A11, A13, A31, A33. That's our minor there. So we find the determinant there, and so on with A23. Have A23, eliminate the column and the row, and then we have our minor. Our sign is minus 1 to the 2 plus 3, so it's a negative sign. Let's do that for example 7. Here we can choose which row to expand along. We pick the one with the most zeros, because that makes the calculation simpler. So we'll expand along the third row. Expanding along the first row, we'll have our coefficient is 6. We'll have minus 1. Well, that's the 3, 1 position, so the power 4. And our determinant then will be 2, 9, 2, 4. And then we go to our next position, plus 5, minus 1 to the 3 plus 2 to the 5, so there'll be a negative sign there. Our minor, crossing out the third row in the second column, so it'll be 4, 9, 1, 4, plus, well, our coefficient there is 0, so we don't need to go any further. In those calculations, 1 to the power 4 is 1, so we'll have 6 times 2 by 4 minus 9 by 2. We look at the sign here, we've got minus 1 to the power 5, so it'll be a minus 5 times 4 by 4 minus 1 by 9 plus 0. Multiplying that out, we'll get minus 60 minus 35 is equal to minus 95.